All right, well, here goes. We'll keep us on schedule. Thanks again for joining us today and for sticking around for this afternoon's discussion. And I hope you all enjoyed the enthused lunch break upstairs. I heard the inspired conversation myself, and I have it on good word that it might have been the most enthusiasm we've seen at a midday break in a long time. And so that's great. I think it speaks to, it's certainly not the MC, maybe the topic. So thanks again, guys, for sticking around today. Now, of course, we have a snowy day here in Boulder, and we saw a strong shift from in-person attendance today to remote. So if you're joining us remotely, thank you very much. Of course, today's proceedings will have a life of their own online after the fact. And so we encourage all of you here, if you're joining us remotely, to engage in that chat. And then if you're here remotely or in person, to engage with it after the fact. It'll be posted online on our website. We really want you to take this to your colleagues, your network. We're wading into some new territory here at Silicon Flatirons, and we want to leverage your networks and your colleagues. Now, as noted this morning, the topic of data infrastructure, strictly speaking, is new to Silicon Flatirons. And I'm grateful that Professor Sturden so graciously supported the topic and the idea to expand today's agenda to include this afternoon. Typically, we break for lunch, enthusiastic or not, and folks would head their own ways. But wait, today, we're going to stick around for more. So, as I'd mentioned again this morning, I'm new to this role, and my main priority is quite simple. I don't want to mess up a good thing. Stakeholders from academia, industry, not least the legal profession, if you look at our panels, policy wonks, entrepreneurs and innovators, and civically minded around Boulder in Colorado continue to look at Silicon Flatirons as a trusted space for informed, often expert discussion around the technology issues of the day. Well, I tend to think that this is a pretty hot topic here today. Now, given the incredible 25-year legacy, I couldn't possibly see both our annual flagship conference that wrapped up a month ago in February and also today's annual AI conference pass us by without taking a preliminary look at the critical infrastructure that undergirds so much of what we do. Whether it's artificial intelligence, as we saw today, telecommunications and platforms, spectrum and space policy, and yes, entrepreneurship and innovation. The topic of data infrastructure touches all of that. And those are areas where we spend a lot of our time. So this is the common denominator. Now, the historic investment and expansion in data infrastructure that we're currently experiencing binds all of that work together. And quite simply, it's driving our state and regional economies, likely keeping them on an overall growth trajectory. Of course, without this unprecedented investment in data infrastructure writ large, we'd likely be in the midst of economic recession nationally. Now, just because this topic is interesting, important, and interconnected with so much of the other stuff that we're doing and focused on, that's not necessarily reason enough for Silicon Flatirons to lean into the topic with all it's got. However, my gut tells me that this is a topic we should lean into, and that this conversation is one that we can contribute to, however helpful. So that's the ask of the audience today. Whether you're here in person, remotely, you're joining us after the fact, think about what you hear. Weigh that against what you're seeing in the economy, in your local community, at your state house, and give us some advice. How should we engage in this topic moving forward? How do we get it right in our outreach and our programming in doing more in this area of data infrastructure? Now, since I am new to this role, another theme of today, I feel like I should take the right opportunities to introduce myself a little bit more. I'm not just this Minnesotan who transplanted to Boulder and end of story. You know, there's 15 years of stories I could tell you. That's why I wrote it down, because there's a lot of tangents with this topic. So it seems like a good opportunity for me to tell you a little bit more about myself and how I found myself attracted to this topic. So here goes. For me, the idea of getting it right, or more appropriately, trying to get it right, it's been a through line throughout my professional career in various roles, whether I was an academic researcher at the University of Minnesota, University of Illinois, a consultant, a one-time state legislator in my home state of Minnesota, or a recent state technology official. The through line, trying to get these technology questions right. Now, as an academic researcher, one of my early projects was making sense of the now 30-year-old Telecommunications Act of 1996. I was dealing with it like a decade after the fact, but nonetheless, it does date me a little bit. And I was intent on translating its opportunities, its restraints, the resulting playing field for local communities, for providers, for tech firms, for policymakers. Now, mind you, again, that was a decade after the bill passed, but still a while ago. Now, as I transitioned into a consultant role during the ARA era of 2009, 2010, huge investment in infrastructure and in telecommunications infrastructure, I had the chance to work with local governments that were interested in building out their broadband infrastructure. Data centers and co-location facilities were the talk of the day. And then in 2013, I had a chance to take that experience to the Minnesota State Senate, and as a legislator, among my tech-themed interests, authorizing state tax incentives to spur data center investment. Sounded like a hot topic in 2013, and well, it hasn't gone away. And so, of course, I tried to do the right thing when I was in that role, and also make sure that I wasn't doing two things at once. So for the record, I was not consulting while I was creating a tax incentives for data centers. It was one or the other. I retired from that consultant role, and then when I was unceremoniously retired from state office, I tried to unretire that consultant role. So it was one or the other, never both at once. But that's a story for another day, that 2016 election, let me tell you. So in all those roles, I've been interested in exploring how data infrastructure, writ large, contributes to local innovation ecosystems and supports related startups, suppliers, tech-based businesses, the whole gamut. In short, how does this infrastructure contribute to competitive economies, whether they're at the local, state, regional, or national levels? I don't want to overstate this work, but it's been an interest, guys. And so I think that's one theme of this afternoon, the mounting pressure to invest, to expand, to incent, and to build out, all in an effort to be competitive in this wildly changing 21st century tech-driven economic landscape that we find ourselves in. So how do we support local communities, other stakeholders in the face of that pressure? Now, in all those roles I enjoyed back in the day, I saw local governments tend to struggle with how to approach a new, relatively complicated, and certainly relatively technical issue. Data centers, broadband build-outs, co-location facilities. Things have changed a lot since then, but nonetheless, I see that struggle continue in some cases. And in those 15 years since then, the issue has become considerably more urgent, it seems, if not complex, and both the local and state governments that often struggled then might continue to struggle today. Or at least they might struggle in how to approach the ask, the opportunity, or the obligation that's before them, especially when you weigh it in front of all of the other agenda items before a state or local body. Now, just as we saw states race to create incentives a decade ago, we're once again seeing states reconsider, restructure, or reverse course on some of those development tools. However, state and local governments remain at the forefront of regulating, permitting, and incentivizing today's data infrastructure and its expansion throughout the country, with the sum of those state and local decisions contributing to our national data infrastructure capacity, distribution, competitiveness, and strategy, if that's what you want to call it. So this seems like a good topic for us to explore here at Silicon Flatirons. And in setting the stage here, perhaps I've overstated the urgency of the moment a little bit, but I suspect not. Perhaps what we'll see is that the path forward isn't wrought with hyperbolic promise or doomsday peril, but rather a careful, measured, and thoughtful consideration of the trade-offs, the right sizing, the right locating, and the transparency that's needed to get it right. I guess we'll see. Now, just as Silicon Flatirons is trying to get it right when it comes to taking on a new topic such as this, for our panels this afternoon, the question is similar. How do we, as state and local policymakers, investors, industries, and informed citizens, put ourselves in a position to get this historic investment and expansion and all that that brings? How do we get that right? So for better or worse, we've loosely organized the afternoon panels into two sides of the formula to build a data infrastructure for the future. On the demand side of the equation, if you will, we welcome perspectives from real estate and land use, critical infrastructure, energy, broadband connectivity, and not least, local private sector investment. Altogether, our first panel will speak to various demand side factors, from hyperscalers to edge capacity and those everywhere in between, driving the historic investment in data infrastructure, and in particular, data center expansion. Now, on the supply side of the loosely fitting equation that we've established here, or I've established here, for better or worse, we'll hear from perspectives reflecting state and local regulation, energy production, and public interests concerning energy consumption, land, and water use. Our second panel will bring to life various considerations that either balance out, push against, or support that data center and data infrastructure expansion. Now, at the end of the day, we're going to open the floor to cross-cutting discussion that we hope spills into Betcher Hall right next door for our afternoon social reception. And throughout the proceedings today, we'll do our best to capture the conversation and then report back to you on next steps, what we heard, where we might go from here. And so once again, without further ado, don't let me stand in the way of a great agenda that we've put together for you today. I'd like to invite Maddie up to the podium to introduce our next panel. Thank you.
Good afternoon, everyone. My name is Maddie Castellano. I am a second-year law student here and also the current president of Silicon Flatirons student group. I am pleased to introduce this panel on the demand side of big data. Our moderator today is David Reed, a senior research associate at CU and a senior fellow of the Spectrum Policy Initiative. Joining him as panelists are Jeff Casey, a director at Burns & McDonnell, Gordon Dolven, Director of Data Center Research at CBRE, Casey Lide, Partner at Keller and Heckman, and Jason Schwent, Member at Clark Hill PLC. Please join me in welcoming them.
Thank you, Maddie. I appreciate it. So, good afternoon. I want to welcome you to this session on the demand side of big data. I am an engineer, and demand is an economics term, an issue, but we're going to dig deep here on the question of how this dramatic increase in computing demand is pushing data center investment and resource consumption. So over the past 2 years, the conversation around AI has moved very quickly from the algorithms and applications to something much more physical, infrastructure. My background in broadband and some of the others on the panel, we're quite comfortable in talking about infrastructure, but this is a new player or new piece on the chessboard. So what we're seeing now is that the rapid expansion of AI, cloud computing and digital services is driving an equally rapid expansion in data infrastructure, particularly data centers, fiber connectivity, and the power systems required to support them. In many ways, the digital economy is revealing itself to be deeply dependent on very traditional forms of infrastructure to meet the demand: land, energy, networks, and capital investment. The scale of this moment is striking, with over, I went to a source that was from late last year, 1.5 trillion committed over 4 years from the US high-tech sector alone in this space. Across the US, and by the way, if you compare that to how much is being spent on broadband, it's already exceeding a lot of what's been done on broadband. So this is a significant investment. Across the US and globally, we are seeing unprecedented demand for new data center capacity. That demand is being driven by a range of forces: hyperscale cloud providers, the continued growth of streaming, gaming, and other high bandwidth applications, and of course, AI model training and inference. What was once viewed as relatively specialized part of the technology ecosystem is now emerging as a core component of the national critical infrastructure. But with this expansion comes a set of questions that reach well beyond the technology sector. Communities are beginning to grapple with issues like land use, water consumption, and energy demand associated with the large-scale data center development. Electric utilities are confronting what may be one of the most significant new sources of electricity demand, or supply as we may talk about, in decades. At the same time, policymakers, investors, and infrastructure planners are trying to determine whether the current surge represents a sustained structural shift in the digital economy, or whether some of the investment may be running ahead of long-term demand. In other words, the question is not just how fast data infrastructure will grow, but how we manage that growth responsibly and strategically. That is exactly what we hope to explore in this discussion. As Matt just noted, we have an excellent panel with us today to discuss these issues. Together, they bring a practical, interdisciplinary understanding of how these projects actually get planned, financed, permitted, and built. Our panelists have been introduced earlier by Maddie. What I'll do now is I'll ask each panelist to briefly introduce themselves and share how they came to work on issues related to data infrastructure and data center development. So Casey, let's start with you, and then we'll just work our way down.
All right, my name's Casey Lide. I'm an attorney with Keller and Heckman in the communications and technology practice group. I'm based in DC, but we have a Boulder office, and I'm glad to have had the chance to come out here and hang out with my friends in the Boulder office a little bit. I'm here on the broadband infrastructure side of things. Our practice group has a broad communications practice, everything from fiber deals to spectrum licensing, pole attachments, and then kind of up the stack a little bit to privacy and copyright and things like that. But my focus has tended to be on infrastructure over my career. And we've seen a number of cycles happen on the demand side, especially with fiber, dating back to, as Matt said, in the 2010 timeframe with ARA and BTOP. We're at a really interesting place right now, and we'll get into specifics in a little bit. But from a supply perspective, where a lot of attention is being put on what's called the middle mile in connecting data centers. At the same time, there's a lot of attention from a policy and funding perspective also being put on the last mile, reaching residences and businesses who just use broadband. So you have these two things happening at the same time and burgeoning growth happening at the same time. And as we'll talk about in a little bit, the scale of the growth, particularly between data centers, connecting data centers to each other, getting the information out of the data center for AI purposes is something that I don't think the industry has really ever seen before.
Jason?
Thanks, Casey. My name is Jason Schwent. I'm a member with the law firm at Clark Hill. We have offices in Denver and Boulder. My practice, I'm focused in the cybersecurity and data privacy group. My work in this space has largely been in advising my clients with respect to risks in adopting AI technology and rolling it out, and advising with respect to and counseling with respect to their adoption and work in the space. As it relates to the infrastructure, those things are fairly closely related, as we've been hearing and we will hear more about. That adoption is something that we have a lot of predictions and we have a lot of thoughts on where that's going to go. But in terms of actual real data with respect to that adoption, a lot of that data is still out. And we're still waiting to see where that's going to be. And so in counseling my clients and then looking at the risks involved in the adoption of AI technology, one of the things that we do consider is what is the market going to look like in 5, 10, 15 years? The types of investment we're looking at, we're not talking about small amounts of money, small amounts of energy, small amounts of land that's going to be committed to this. And as Casey had mentioned, there's a lot of places to invest when it comes to this technology. Is the investment in data centers the right place to be investing, or is it better spent elsewhere? But hopefully we'll be having a discussion along those lines. And yeah, I think it should be interesting.
I'm Jeff Casey, Director at Burns & McDonnell, focused on designing and building critical infrastructure. Burns & McDonnell is an employee-owned company, 128-year history of serving clean water and reliable power for utilities. Of course, we've spread out dramatically from our roots today. We fundamentally touch all of the systems that are necessary to make communities thrive. So anything necessary if you're going to build a community from the ground up, would be the infrastructure that we design and build. We're the largest in power and T&D, second largest in telecom and data centers. And so how did I arrive at this moment, I think, was the nature of the question. I'll give you both a personal story and a professional story. Personal story, my dad started a communications business in the 80s and 90s, which was an odd time to be in the communications sector because you could be on the wrong side of a bubble, which I think we'll probably hint at today but not talk about. The other half of my family, my grandfather and my uncle, built coal-fired power plants and managed coal-fired power plants. All three of them thought, you should go into engineering and do what I do. And I said, no, I'm going to do something completely different. Little did I know, 20 years later, I'm working at the nexus of power and data. And so really, joke's on me for not listening to them much sooner. I have a unique role at Burns & McDonnell. I have an engineering background, but I actually sit on a small team that focuses on solving clients' most toughest challenges. and that's coming up with creative or novel commercial solutions for those challenges. That could be investing in infrastructure, developing infrastructure. That could be investing alongside of our clients and what they're trying to accomplish. And that could be developing new products and services or solutions for what our clients are going through right now. And some of that's the advisory side. Some of that's helping them on simple design things, and other things is bringing that infrastructure to life. I've been at Burns McDonnell my entire career, 18 years, and have held a number of different roles, from large programs, major projects, telecom, technology, development, and now the role I'm in today.
Awesome. Well done, Jeff. My name is Gordon Dolven. I'm based in Denver. I work at CBRE, the commercial real estate company, and I cover data center research for North America. What does data center research mean? It can mean a lot of different things. I track supply, demand, construction, absorption, pricing, all those same types of metrics that you would assume you would want to track for office, industrial, retail, multifamily, traditional asset classes. But in terms of a differentiator, I truly believe this is digital infrastructure, not just digital real estate. This truly is mission critical types of infrastructure that we use every day, whether it's personally or professionally. I want to thank Matt for bringing me in and for leading this conference and this discussion as well. How did I get here? I came out of school and I was actually in financial services, and I was banging my head against the wall trying to sell wealth management products to people who had no interest talking to a 22-year-old whatsoever. And I thought, what is a disruptor that I could get behind in terms of something that can change that type of industry? And it truly was the automation and the technology that's providing all of these products and services today, which is backed by data centers, fiber, cell towers, all the digital infrastructure that we use. So happy to be here, and thanks for having me.
All right. Well, I'm going to keep it down there with you, Gordon, with this next question, since you have a great passion and focus on digital infrastructure. So where do you think this is going in terms of realistic, immediate, and sustained growth in data center expansion? Or what are the likely impacts on things like land use or other factors that maybe are of significance?
Yeah, if we all had a crystal ball, we'd be out of this room doing something else. But I think on the demand side is where I want to focus. I think maybe we go back in time and just talk about how we got here. So I think about the origins of data centers and why you actually need data centers. I don't know if everyone remembers back in the day, every office and every company within that office building had their own IT closet. And that's where you stored all your files, all your emails, all your documents. This is back in the day when maybe you used a fax machine. Maybe you were using your printer on a daily basis. Well, now, instead of every single company having their own mini data center in every single floor of every office building in America, we're now able to commingle those assets and to share them under one roof in a data center. So the joke is that the cloud has four walls, truly has a meaning to me. The cloud is not some esoteric, destination for all of us to travel to every time we use our smartphone. No, the cloud sits in a data center and the servers within a data center. So if you go back to why we were using data centers in the past, it was simply to send emails. It was to do web search. It was to use, very, very much Internet 1.0 types of tasks. And then we sort of formulated the social media types of applications that started on our smartphones. So if anyone remembers, Facebook was first launched across universities and campuses, and they were a huge demand driver for servers. And everyone thought, why do you need servers for a dating website? Like, are all these kids really using that much server space to just talk to each other? But in actuality, it became a social media network and a fabric for people to share content, to upload content, to communicate with each other. And then we got into streaming services. So instead of, absorbing information through over-the-top television or through traditional ways of getting content, you can now stream things. And then it's evolved over time into these applications that live and breathe on our devices, either personally or professionally. And now we're where we are today, which is at sort of this inflection point in terms of AI adoption. So I think it's truly a matter of, if you continue to get more productivity and if these tools continue to help you, then you will adopt them and utilize them more. And in my personal opinion, that will only continue as the technology and the use cases continue to grow within our professional lives. So that's where the demand is right now. It's scattered across all Fortune 500 companies adopting AI tools internally. The data has to go somewhere. And I think a demand wave that we have to really be keen on focusing in on is that certain workloads are not meant to just sit on the public cloud. Certain workloads a company wants to have internally on their own servers, either from data protection, data privacy, or from a competitive reason. But I do think the demand is coming from not only the cloud, but also from on-premises, enterprise, colocation servers. It's a wave that really touches all ecosystems of the data center industry.
So, it's interesting that you mentioned Facebook or Meta now, that they were early on, in terms of establishing their own data centers and linked to that their own backbones, right? And so the notion of a public cloud versus a private cloud emerged because Meta and Microsoft and a lot of the big tech kind of took the data centers and connecting to them for what they said were the need for managing their subscriber quality of service, because they could control it. And so that you've got now several private networks that with basically the data centers being key components of that. And do you think that has any implications going forward you mentioned public network, that's why I'm kind of, where does the public network swim among all these large private networks that are basically anchored by large data centers? And I know that.
I think every industry and every company will approach this differently. Like the typical demand drivers were from the technology companies, which we talked about, the financial services companies, very data intensive in terms of what they do and the products they offer to everyone here, and then the healthcare companies in terms of data security. But just think about the future in terms of any company doing research and development, any company trying to optimize or more efficiently build a new product or service in the R&D side, building tools and making sure those trade secrets are kept internal. I truly think that is where sort of the public or the private AI or the AI sort of demand wave will continue to rise. It's not necessarily, in my opinion, something that may be forced from a regulatory perspective. It could be a focus of a C-suite perspective or a board of director perspective. So as these companies become more defensive in terms of cybersecurity risk or from trade secrets getting out, I truly see that as helping the sort of the private infrastructure and build out of this entire wave.
Right. On the public side, we had companies like Equinix, right, that had an internet exchange point, and IXP. Sorry, guys, I'm told you I was an engineer, but trying to explain somehow this infrastructure is evolving. And part of their business model was to have an internet exchange, a peering point, but also to have a data center sitting next to that, right? That if you weren't a big player like Meta, you might be able to still have support in the cloud for your services, right? And I don't know if anybody else on the panel here wants to jump in on what.
Yeah, I mean, I think the note about the cybersecurity concerns, the privacy concerns, the IP concerns, quite frankly, I think that is going to be a significant driver with respect to this demand. I think those aspects of things, I don't know that regulation's necessarily going to drive it. I think you're right that I think other commercial factors are going to push that. I mean, we were already seeing, there was a case this month where the use of AI can waive your attorney-client privilege. Now, that's not necessarily going to affect demand necessarily, but I think those sort of decisions in an area where we have a lot of assumptions about how things are going to proceed and about how things are going to work and how this technology is going to be adopted. But I think there still are these aspects of the law and with other commercial considerations that we don't really know how they're going to play out yet. And I think they're going to have a significant impact on a lot of this. I also think there is a bit of a chicken and the egg sort of argument and scenario at play where if you have a bunch of supply on one side, where you have a lot of this infrastructure there, then people will find if it's cheap enough and if you've got an abundance of it, then there will be a use for that people will find a use for it. If there isn't, there may be alternative technologies that are developed to handle that sort of thing. I mean, we talked about with television distribution. That was handled entirely different 25 years ago. It is an entirely different model based largely on the fact that there was this sort of broadband capability that was out there. Other technologies may be developed, or there may be other solutions that may be better for certain industries that won't necessarily use the data center or that sort of backbone to develop that we don't know about, which is where I think there is still a lot of uncertainty. I know there's a lot of investor talk about where this is going to go and in terms of where markets are going to be and in terms of what sales goals are going to be hit. The reality that hasn't necessarily developed, and I think there's a host of factors affecting that. And I think it's more than just whether or not there are servers in a building with power to drive that. I think there's a lot of other things that are going to come into play that I think as usual. I mean, these same sort of issues, we talked about a lot of these when the internet was first started being commercialized. There was a lot of uncertainty in terms of where that was going to go, and there was a lot of thoughts in terms of what we're going to need to make that work. Some of those panned out, some of those did not. And so I think we're probably going to be seeing a similar thing with a lot of this development. But that's why I firmly believe there's a lot of uncertainty here. I think there is a need for a lot of this bandwidth and a lot of this supply side. But I think there can also be, if you produce a lot of it, then there will be people who will use it. And I mean, that's always been the case.
I think we're in a very different place than we were 10 years ago, not just in terms of the magnitude of the investment, but things were more, I don't want to oversimplify this. There was a more egalitarian approach or a more of a democratized approach to all of this a few years ago. Using the Equinix example, right? A neutral host site, effectively. Somebody could come in and stand something up in Equinix, and they're still there. Mm-hmm. But the investment is being made by a handful, by and large, by a handful of entities who are plowing vast amounts of money into gigantic data center complexes and buying vast amounts of fiber to connect them. And they control it. You know, they may have a vast amount of fiber, connecting them, a huge supply connecting these data centers. They may not even be using it all. There may be a ton of excess fiber available, but they may not make that available to others because they invested it and they control it. So that's very different than supply just generally being available, right?
The only thing I would add is the optimist side of me would say, like, we didn't understand what the iPhone would do until the App Store was there. The App Store enabled a new economy and things like Uber, which we never would have had if we didn't have the underlying infrastructure to support it. So do I think that's going to come from here? No, we'll probably have a lot of losers before we get to an upside case of Meta controlling the rails, for example, of an app store for AI. A lot of predictions show what that will or won't look like. I think nobody knows today, but if we go back just a decade or 2 decades, we couldn't paint the world that we see today as it is. So I think it's fair to think like, hey, we have 5 companies controlling the rails. In many industries, it's like that. The question is, how does that get used and how does that get monetized and who benefits? And maybe the downside is, who do we need to protect from a policy or regulation standpoint?
Okay, well, Jeff, let me stay with you since you've spent a lot of your career supporting the expansion of critical infrastructure. So how does the data center boom, if we use that term, compare? Some have called it a bubble, but any observations as well on the energy component on the demand side of the equation?
Yeah. It is the largest or the most capital-intensive deployment of infrastructure broadly that we've ever seen as a society. And I'll put that in context. That's not hyperbole. That's real world what's going into the ground. And the impacts to that and the externalities to that are crazy. But maybe if we backed up and said, have we observed it before? I think that was your first question. In the energy sector, yes. Electrification, post-war, we had 2.5% to 3% load growth, plowed incredible amounts of capital into the ground to build the electric system. 60s, 70s, 80s, 90s, did it again through coal and natural gas generation. Again, 2.5%, 3% load growth. Again, plowed an incredible amount of infrastructure into the ground to support the grid, the modern grid that we have today. That's both generation and T&D assets. But if we back up to pure demand and the underlying demand attributes that exist, we shouldn't take for granted that AI is the fastest adopted technology, faster than cell phones faster than the internet, faster than TikTok, 3 months to 100 million users, first technology to ever 1 billion users in a year. I think I saw a number 800 million monthly users. That's not people subscribing yet, but that's an incredible amount of use as an underlying signal or sign that something is happening, that there's a groundswell there. I think that's really incredible, and we shouldn't forget that. I think we also need to think, as we talk about the various types of data centers, historically, we talked about a data center that had a rack, a 19-inch rack that was 5 to 15 kilowatts. We're talking about the load of a couple of houses. We quickly went to 20 to 40 kilowatts. Now we're talking about an EV charger, a DC fast charger on the low end. And then some of the frontier racks, again, we're talking 19 inches of floor space. We're talking, 300 kilowatts to some of the predictions for electricity consumption. We're now talking a production line in a manufacturing facility. We're talking about 2 to 3 city blocks of electricity simply to serve a single rack. The size of infrastructure that you need to build then to support that, because it is also, I'll say, a land grab. You want to get the permitting, you want to get your grid connection, you want to get your water rights, you want to get all of the things necessary to serve this done, and you want to buy the land once, you don't want to go back. Results in some of the largest data centers being 5 to 10 square miles. That is incredible. We're talking 1 million square feet under a roof, and we're talking 30 to 40,000 racks. So if you play in the top end of a frontier rack, you say 30,000 of those in a data center. Now we're talking about a medium-sized city worth of load in 1 million square feet. And so then we take that one step further into the world that I work in. I've been in the electric utility industry for 18 years. We've had 0% load growth for 18 years. And almost every year we've had record levels of investment. When I started in the industry, I think we were around $80 billion of investment in the T&D and generation sector. Fast forward to 2015, we're around $105 billion. Now projections this year suggest $220 billion of investment, like unprecedented amount of investment into the electric grid to support this. And I think the challenge is that takes away from everything else that was already happening. Utilities weren't attracting always the best talent to work for them. They weren't, overstaffed looking for things to do. We had an incredible amount of work in front of us prior to that need. So going from flat load to some load growth, predictions 2 to 4%. To put that into perspective, 2 to 4%, we're talking about doubling the size of the power grid by 2050. Can't fathom that. Like in my lifetime, if you would have said we're going to double the size of the power grid and we're going to add 1 to 2,000 terawatt hours of generation to our system, while, and we heard on the panel yesterday, while data centers may take up 12 to 14% of that total generated asset, like that's an incredible amount of investment and infrastructure that goes into the ground. And so my final remarks here would put this scale into context. So if we bring all of the major investments that have happened in our country to present value, and we look at them through the lens of today, we're talking about the capital intensity of the telecom sector, that total build over 20 years happening every 2 to 3 years for data centers. We talk about the highway system built over 25 years, I think. We're talking about that happening every 1 to 2 years. Like this is unfathomable to me. Like we're building an interstate highway system every year. If you talk about the generation system, the 40 years of investment in generation, we're doing that 2 to 3 times over in a single planning cycle. And the rail build out, again, equivalent to that from the 1800s every couple of years. And so the only thing that I can equate this to is the Industrial Revolution, which took 80 years. 80 years to put $5 trillion worth of infrastructure and equipment and machinery and factories into our economy. 80 years, we're talking about doing that amount of investment in 5 to 10. So the speed and intensity of this is incredible, and it touches every part of our society and our economy: manufacturing, power, generation, T&D, telecom, workers. Like this is the most incredible investment opportunity or risk that our country probably has ever seen. So that was a long answer to a simple question.
Well, that's a good
It's a yes and.
Yeah, well, that's a great answer. I guess, is the demand differentiated enough for some of these different players that are major investors, Apple versus Google, with search versus what Apple wants for the smartphones and their AI, to that we might see a lot of, I know we're not the supply side, but just different experimentation, so to speak, on how to get that
How to get access to the grid?
Yeah, well,
Or-
well, both the grid as well as having, enough thrust behind being able to do the inference for their AI. Because, you've got Facebook or Meta that's out in front on the open compute project for them, which is really
Yep.
kind of customizing how they want their data center servers to work. Elon Musk wants to put it up in space. And the question is, are they all dealing with the same requirements, so to speak, of latency because the applications they're supporting or are all about the same? Or can SpaceX tolerate some more latency with satellite links and therefore kind of have different solutions there and a different approach to making it work?
I'll start by saying they're all optimizing towards the same scarce resources of power, land, water, and fiber.
Okay.
Like everybody is optimizing towards those 4 attributes, and everything after that is a trade-off decision that you're making to serve your need, and you're optimizing around that. And when we talk about data centers being an arms race of competition, it's typically competing across county lines, state lines, utility boundary lines, competing across where I can get land, where I can get an option on land, where I can get access to water, how I can play 2 utilities against each other, how I can apply for the same grid connection for the same load. They may also have a developer or an SPV that's chasing the same opportunity below that. And so I think we're still in the role of consumption and optimizing everything that's out there until there is scarcity in one of those assets, which scarcity in gen connections happened substantially faster than I think I probably would have predicted. Maybe that was naivety on my part. But I remember hearing some of the digital infrastructure investment leads saying, oh, we're 2 to 3 years out from, transmission capacity. Then after that, 2 to 3 years out. And we've consumed all of that today. 23% of utilities say 100% of their capacity is being requested for data centers, so implied doubling the size of the grid. But I don't think differentiating the type of inference, say Meta versus Oracle is doing is the important thing. I think it's separating, is it cloud and storage, is it training and inference, or is it an enterprise load? That is how you differentiate the size, the scale, the location, the needs of those assets, not is Meta versus SpaceX doing something different? Yes, they have different requirements, but probably not as dramatic as, is it a cloud, is it colo, is it built to suit, or is it a hyperscaler?
And one more follow-up, since we are talking a little bit about energy here, to the extent to which there's, been the proposal by the current administration of allowing big tech to basically build their own power sources, you think that is going to play a potential major role in being able to kind of meet some of the timelines that you were talking about earlier?
Yeah, we're talking about seconds to download an app and to have a search query that is equivalent to a light bulb. And we're talking like on one side, and on the other side, we're talking about 7 to 10 years to build real assets and real infrastructure.
Right.
And so there's definitely friction and a mismatch. And what we're seeing is everything. Every single strategy that you could imagine to get access to either T&D resources or generation resources is on the table. Developing it yourself, applying for grid connections, applying for competing connections for the same need across state lines, utility lines, et cetera. Buying developers, buying generation, developing behind the meter, bridge to grid while I wait, fully self-supporting, 10 gigawatts of nuclear, like maybe coming back online or being used just to serve data centers. I mean, every single strategy that you could possibly think of is in play here. Do I think behind the meter, long-term data centers served only by generation that they own is the solution? No, probably not. It is really hard to build a reliable generation and transmission and distribution grid. So I believe that is a temporary solution while they wait for capacity on the grid.
I guess I'm still, the question I come back to, or the issue I come back to, is that with a lot of these particularly AI is clearly driving a lot of the need for this data center space. And the question I come back to is that with a lot of these AI companies, they are going to need the sort of infrastructure that Jeff's been talking about. That in order to be profitable, they have to be at this unheard of level of growth and infrastructure in order to be successful as companies. They're betting that they're going to get there. And they've sold a lot of the development of this infrastructure on the promise that they will get there, and without any results to back that up necessarily yet. And all of it is dependent upon them getting there and it being successful and profitable at some point in the future. So we have to build this enormous, unheard of amount of infrastructure in order for them to be profitable. And then we will see the results of all this really happen. When the technology and its development is not, the early results in terms of adopters have the results have been mixed at best in terms of people and the results that they're getting. So there's this heavy bet on all of this infrastructure, massive amounts of infrastructure being built. And as Casey noted, being owned by these private companies in large measures, as opposed to necessarily some of the infrastructure you were talking about, Jeff, in the past, where they were publicly owned, where these were public utilities that were open to the public and therefore anyone could use it. This is mostly private development that's being funded on the hopes of profit in the future. And if any of that falters or any of that doesn't develop or doesn't come about, what are we doing with all of this infrastructure that's being held by private companies that may have zero value? And that is a big question, I think, as far as regulation, as far as the thoughtful development of this infrastructure is there a downside to having too much of the infrastructure? I think past history has shown that when you have, at least when it comes to internet and bandwidth, if you have it, people will use it and will exceed it. It gets used up. There's a use for it. But again, that was largely public in terms of its development and the way it's been used. As Casey noted, this is more of a private development. So how does an overdevelopment in that private space translate to public benefit if those companies can't turn a profit, if the profit doesn't materialize? They promise it will, and they promise that it's going to come, and they promise that if we have all of this infrastructure and we have this giant capability, then the AI will be really good and it will be that much better and everybody will benefit from it. Trust us, we'll get there.
Can I give you an answer, Jason?
Yeah, no, I really, yeah.
History would tell us that as a society, we will bail out shareholders and we will will allow the common person to be harmed. We have had that happen many times, and we will probably repeat that bad cycle if this scenario plays out that he described. That is probably the unfortunate truth.
Yeah, that's fair. Yeah.
We bail out shareholders. We do not bail out citizens.
Well, Jason, let me.
No.
To the bar.
No, exactly. No, I excellent point. No, that is history. Yeah.
Let me keep it with you and given your experience with the local companies and how they're approaching this moment. And you mentioned some about risk here, but what are your observations on this?
Yeah, I mean, I think there is a wide appetite for a lot of this technology. I think that is unmistakable. And Jeff, you cited a lot of the statistics in terms of adoption, in terms of people moving into the space. I think there is a healthy appetite for a lot of this technology. As a lawyer, viewing a lot of this, I see some of that appetite exceeding the thoughts given to the risks associated with it. From my side of things, there is a lot of concern, and Gordon, you mentioned it too, in terms of privacy, IP, those sort of concerns in the use of AI, particularly where you're using AI that is not segregated. That segregation requires an investment in that sort of infrastructure that we're talking about so that you can keep your data separate from everybody else who's using the AI. And I see a tension from a lot of the executives that I work with where they want this technology because of the promise of what it's going to bring. lower labor costs, lower costs in terms of developments, faster development. They want all of that. But then when faced with a lot of the risks that come with it, then they start to back off of some of it. And I've seen with some early adopters even that as the technology's rolled out, they found problems with it. And they've backed off then in terms of its adoption. It hasn't panned out necessarily in their development. It hasn't panned out the way that they had hoped. And that is where I get a lot of this concern in terms of, is this trend going to continue, or are we going to see these sort of, well, it's not really getting us where we want to be. So maybe this isn't the best place for us to sink all of our money and all of our development. That's the sort of appetite and sort of the tension that I'm seeing with a lot of my clients in terms of adopting a lot of this technology, that it's a bit of a mixed bag, that where some limited uses of it can be of benefit to the company, they can be of benefit to production timelines in terms of labor savings, but it comes usually with a trade-off in terms of additional risks that they're taking on because of errors, because of problems with the data that they're using, because of problems with the data being shared with others and the risks that come with that they're not comfortable with. And that gives me some pause in terms of I'm not sure that all of the predictions are going to pan out. And history, again, would tell me they usually don't in the way that we're thinking that everything's going to pan out, that those predictions usually don't come to fruition, that there is some alternate version that ends up kind of happening. And I think, you know, Jeff's right that there probably is going to be a lot of public bailout of private shareholders with their investment in a lot of this. But I think it also demands of us more careful consideration in terms of, because of the sheer scale of investment that we're talking about, because of the sheer amount of not just money, but of effort, of space, resources that are going to be needed for this. Bailout alone is certainly going to be something that's going to be on the table should anything that I'm worried about pan out. But I think there's also other concerns that we haven't really dealt with, because as Jeff said, this is unprecedented growth. This is unprecedented expansion. And that raises concerns in terms of, is there a cost to having too much bandwidth? I use the bandwidth generically, but in talking about, is there an adverse cost to having too much infrastructure here to support all of this? In the past, that was less of a case, and I would say that there was less of a worry about that somebody would find a benefit to it, somebody would use it, it would be a benefit to someone, and there'd be use. I don't know if that's going to be the same case with this infrastructure. I don't know if that's going to be the same. I am confident that if it is out there, if it exists, there will be some sort of use for it, but I don't know if it's going to be the maximized economic benefit. I don't know if we're going to get a return on that investment, I guess would be my concern.
Now, I don't know where Matt is, but I officially lost control of the session here. We're talking bailouts.
We got this, David. Don't you worry.
But, I mean, I'd like to hear what the other panelists have to say, you know, about bailout. I mean, some of these companies have a pretty large stash of cash, right? I mean, it's not, they're not, you know, Apple has got a lot. But
Well, that's a distinction between what's happening now and what happened in the dot-com era, right?
Yeah.
I mean, those companies who speculated heavily at that
Right.
time were on a prayer and a hope and a dream.
Yep.
Right? And these companies have vast piles of cash that they're able to put into this. A lot of it basically on spec, and so it's a little bit of a different scenario. I don't disagree that, you know, there's.
I wasn't rooting for a bailout, nor was I suggesting one is needed. I'm saying, should the worst happen, history might paint a similar picture.
Yeah, absolutely.
Just to be clear, just to clear my good name, David.
Okay.
Sorry, please, Casey.
Well, on the fiber side of things, we can transition to that.
Yeah, go ahead.
There are a lot of parallels to what happened, again, back in the dot-com area. There was a lot of fiber put in the ground. And then a few years later, we had WorldCom, right, blow up. And a lot of that fiber sat there unused. Meanwhile, lots of people didn't have good internet access at home. The resource was not put to its highest and best use by any stretch, right? And so let me back up a little bit and then so when we talk about fiber cable, We're talking about strands of glass within a cable, and it always comes in multiples of 12 strands of glass within the cable. And so for a long time, you'd have a 72-strand fiber cable, or maybe 144-strand fiber cable, and that would be enough to, for a good metro scale network, or maybe run by a utility or something like that. And that was a lot of fiber. You could, medium-sized city, all the people around, and that was you felt pretty good with that, right? Well, over the last few years, it's changed a lot. And if you are a fiber owner or developer, and you even want to have a conversation with the hyperscalers and Meta about connecting to data centers, 864 count is table stakes to even talk to them before they'll even talk to you about it. So I'm working on a project out further west than here. It's a 300-mile link between two data center complexes, if you will. And the plan is 8 microducts. And in each of these 8 microducts is an 864 count cable. So you're talking a total of 6,900 strands connecting data centers, right? So then let's talk about mileage, right? So right now there's about 95,000 route miles of fiber throughout the United States. And according to one estimate, in order for AI to scale effectively, whatever that means, we need it to be about 187,000 miles by 2029. So that's doubling the route miles throughout the country. Now, is that going to happen? No. I just really don't think that's going to happen. And so this gets back to our point about, there are some constraints on power. I mean, is it really realistic we're going to make those investments within 5 years? It just boggles the mind. I don't see how it works that way. And some of the same thing is true with the fiber investment that everybody says is necessary for AI to reach its true potential. And, there's some other things going on here that are a downward pressure on being able to meet these aspirational goals. For one is fiber supply. So it's really hard to get high count fiber right now. And generally, and this gets back to kind of the balkanization of the industry and the only 5 companies really being able to do it. Meta just did a $6 billion deal with Corning for Meta to get, a lot of supply from Corning. If you're looking to do anything high count right now, it's really hard to do it unless you're a Meta or an Oracle or anybody else like that. And so that's one constraint. Another is labor. You've got very limited labor capacity out there for people who know how to work with fiber. It's just not there. And so there's a lot of programs trying to boost that, but that's a very constraining force on this. And underlying all of this is the vast pressure for speed of deployment. And so the big providers, if you can, let's say you do have access to all that fiber, and you do have access to a construction crew who can do it. Unless you can do it really fast, then your value to the Metas of the world goes down a lot. And so then you're faced with permitting as a delay, right? And permitting can take a long time. Now there's some legislation in Congress that may make a difference on that, for better or worse. There are a lot of good arguments both ways on that, I think. And so, there are a lot of things that are potential constraints on the investments that we're being told must be made in order for it to be a success. And at the same time, getting back to, is this really the best use of the money? There's a $42.5 billion program called BEAD, which some of you are probably familiar with, the Broadband Equity Access and Deployment Program that was started from the Infrastructure Act a few years ago. Its objective is to connect all of the unserved and underserved locations in the country with broadband of at least 100 meg by 20 meg. Laudable goal, right? Well, all of that money is about to be dispersed basically starting now. The first few states have been approved now, so it's going to start rolling out the rest of this year into 2027. Well, those guys need fiber. They need construction crews. They need permitting. How's all this going to happen? These things go right at loggerheads at each other. And let's say you have a route from Meta, maybe that western route that I talked about with that vast capacity of fiber going from point A to point B. Maybe there's a little town or a little cluster of houses right off of it who are underserved. I'm not optimistic that Meta, and I don't mean to pick on Meta, I'm just using that as shorthand for all of them, if any of them are online watching. But, I don't know that they're going to be very open to the prospect of a lateral connection from their network to go serve these underserved or underserved places? Maybe they would. And maybe this is an opportunity for them from a PR perspective or just a good thing to do. But, it seems to me they could leverage some of this investment to that other purpose as well. But we haven't seen it yet as far as I'm aware.
Yeah, but I mean, so, as a follow-up question for you, the data center is in essence somewhat taking what in the old web services was the application server. It's become a complex, that's become a data center now if you augment it with AI. So it's been part of each application platform, right? Whether it's Google for search or Meta for their social media. And so there's never really been a requirement for the interconnection of different application servers with each other. They all connect to the internet, right? And that's important that we have that interoperability. But it does lead to the question, I think, that I had raised with Gordon about, we're really bulking up the private network side of our infrastructure, right? And if there isn't a very robust public network side that allows those without the scale to be able to do what they need to do to be able to grow, to become the next Google, then that could be a problem. The other question, though, for you is that not only is their need for folks who can connect fiber, as you were talking about, between different locations in the access network or middle mile or even the backbone, you also need those folks in the data centers because you've got a lot of fiber running around in there, right?
That's right. Yeah, the data centers themselves have a huge amount of fiber needed within it.
Yeah.
And that's not something we or our practice have done a lot of. I mean, Gordon may have some insights on that. I don't know, but within the data centers themselves, there's just fiber rolling around in there, and so then that gets back to the supply constraints at the same time.
Yeah. Any other comments here on what's been said before I transition? Okay. All right. Okay. So for my next question here is for the entire panel, and then I've got a couple more, but then I'll open up the question of the floor to questions so you can prepare your questions. Part of putting my professor hat on, I just want to break down the current conventional view of the components or of the root causes of driving demand. So I'm meeting Matt's definition here, so everybody walks away with it. When we say the demand for data centers, I want to have a basically a short discussion of what that means, and then I have a question then for the panel for their reactions to this breakdown and the future trends and the various demand components. So this wasn't a question that was provided in advance, so if you're relying on AI for your answers, you're out of luck. So to begin, that's based, but this is based in part of what you've said already. So we have components of this already discussed. The root causes or the root sources for this demand for data centers can be grouped into several categories here. The first is the foundational model training for AIs, and that's a current primary driver that is real and ongoing. That's driving the need for new data centers. And it is the largest one, and it's used across many applications, OpenAI, Meta, Google, et cetera. For those who, just again, I just want to make sure everybody is understanding what we're talking about up here. A foundation model is a large AI model that's trained on very broad data sets and designed to support many downstream applications. And these are like the large language models, the LLMs. So training one frontier model may require tens of thousands of parallel GPUs, which are kind of the type of processor that you use in doing this training, running for weeks or months. And this is a key reason that firms are building these AI-specific data center clusters. So it takes a long time for this. I said frontier model, not foundation model, so I want you to know a frontier model is an AI platform built around the most advanced models currently available. So they're pushing the limits on the computing power, data, and algorithmic capability, all right? So all frontier models are foundational, but not vice versa, all right? So the second category here is model for demand is model inference at scale. So after you've done your training, the models must serve what we call inference workloads, all right? And that's responding to user queries. And so examples for this include conversational AI systems, search assistants, automated coding tools, enterprise AI copilots. And these services run continuously, and they require large fleets of these GPUs or AI accelerators in order to operate. And so the inference workloads often consume more total compute over time than the initial training, all right? So once you train it, and so training isn't like this big bump and then everything goes down. Assuming you have some success, the inference can be more, especially once you reach millions of users, and you were talking about some of the stats being able to achieve that. So category 3 here is AI integration into existing software platforms. So another major driver is integrating AI into existing products, and we see that with these AI assistants when you're on search or on a office productivity software, PowerPoint, right? You know, you've got your designer now and things like that. So these integrations require large-scale inference infrastructure and are another key demand. Fourth is the enterprise AI adoption. So businesses across many sectors are beginning to deploy AI internally, whether it's finance, healthcare, et cetera. The enterprise demand often involves training custom models on proprietary data sets and operating internal AI systems. This is emerging but rapidly growing source of demand. Then the next category are traditional cloud services, the web services that we talked about. And so these provide the on-demand computing resources delivered over the internet, essentially allowing organizations to, if need be, they can rent or build computing infrastructure if they're not operating, they can rent if they're not operating their own data centers. These services typically include virtual machines, data storage, databases, networking, and application platforms, which support the web loads that you need for web hosting, e-commerce, and mobile applications. So the web services scale, and this is an important point, the web services scale by serving many small independent requests when you're using these services, while AI scales by concentrating massive computation into tightly connected clusters, right? So there's different loads that they place upon your data centers, and that concentration then drives the new design requirements for modern data centers. They can't just scale up without some different design when they're going from the web services where they've been or where they've been to AI in the future, all right? So then the last category here are the forecasted future applications. So there's a portion of these new data centers that presumably reflect expectations about future demand, the AI agents, autonomous vehicles, AI-powered software development, and traditional cloud services. These are still emerging, and really there's a lot of uncertainty, but the infrastructure providers are building capacity ahead of that demand because AI clusters take years to deploy. Back in the broadband days, and I'm showing, maybe dating myself, but if you remember the film Field of Dreams, right? Where they built the baseball field, and then if you build it, they will come. That's what we used to say about broadband networks. You know, if you build it and you have 10 megabits per second, they will come. And you will say, well, of course they will. But back then we had AOL and servers, and we were downloading email, and it took 20 minutes to do that and the like, right? So this is a field of dreams approach, potentially, with some of these applications. So now, for those of you here this morning, not drawing upon Professor Surden's opening keynote this morning, he proposed a rule. And for those who are Silicon Flatiron's community, you know there's the Phil Weiser rule and different rules, right? So the Professor Surden rule is that forecasts of 3 to 5 years can be reasonable, but more than 5 years are problematic at best, right? That doesn't have a good track record. So my question for the panel here is whether these different demand components represent kind of a reasonable set of forecasted demand over a 3 to 5 year time frame. So we've got the best, there's uncertainty here, and we've kind of captured the best we can. And second, what do you think will happen over the next 5 to 10 years? So under the Surden rule, I've got a gotcha question because it's hard to answer that correctly. But will there be new emerging categories, or will they drop out? What do you think is going to happen here with this kind of under this view of where demand for data centers and the drivers for it? So who wants to go first?
Sounds like a well-diversified approach in terms of demand. I think, so the question was the 3 to the 5 to 10, sort of thinking about it down the road.
Yeah.
I think the main challenge is all this infrastructure, to Jason's point, in terms of utilizing it to its fullest capability. We don't know necessarily what those killer apps are going to be until is it the cart or the horse? And so to predict things that far into the future seems like a frivolous activity. But I think it is sort of a sincere approach to think about adoption and utilization of technology, if it's going to slow or if it's going to accelerate, if it's going to continue to be integrated into our lives, or if it's something we're going to walk away from. Jason said results are mixed at best. I think we all are grateful we don't have to print out directions at home before we get on the road and drive from Denver to Boulder to remember, where this parking lot was, where we had to be today. Or maybe some of us like the convenience of watching movies in our houses as opposed to driving to the movie theater. And so in terms of results, I think we won't know the results until 3, 5, 10 years down the road in terms of what we're building out today. I do want to just reference one point in terms of the labor component of this whole demand cycle. In Jeff's world, it's all about the construction side, the electricians, the mechanics, the engineers, the technicians, the plumbers now with site design. As the chips continue to evolve, as the hardware continues to evolve, so will the site designs and the data centers. It's not, the norm for data centers to be built on thousands of acres from a historical perspective. It's also not an assumption to think that they will always build on 1,000 acres in terms of land use. So I think in terms of thinking about things and demand drivers and how things shifts, it all comes down to that hardware piece. And I think everyone agrees hardware will continue to evolve and to change. And as a result, so will the data center. So demand will continue to shift and to evolve as we go down this road in terms of adoption and evolution of these products and services. But the killer apps, everyone points to the autonomous vehicles, the drones, the Internet of Things devices. I'm not so sure that those will be the things 10 years from now we'll look back on in terms of using the most compute in our lives. I think it's the great unknown.
All right, 3 to 5 years, I'll be really confident and say that that chat and search are not the killer apps for AI. It seems obvious that that's kind of the bellwether application that everybody uses. It's very approachable, anybody can use it, but that won't be the thing that transforms our human capital or our workforce. 5 to 10 years, we're starting to already see this, but I see the biggest risk not of what we're talking about here and some incredible downfall, but rather this concept of crowding out. And Casey, you pointed on it, and you just picked up on it on human capital. Like, we're 300,000 to 400,000 construction workers short in our country. We need to bring on in the next, I think, 5 years, another 200,000 to 300,000. AI alone needs 400,000 construction workforce. These are all skilled people. And this crowding out takes away from other things that we need in society. And I also think the crowding out potentially is covering up maybe some soft spots in the economy, like data center growth has covered up 50 to 75 basis points, a quarter of maybe what's actually going on in the economy, and maybe is distracting us from things that we should be looking at. And so my 5 to 10 year prediction is the crowding out effect will start to reveal itself, that some of the underlying things that we were looking at weren't as good as they thought, and we distracted ourselves from things that we actually need in the name of things like national security in exchange for like doing the things we should have been doing. So that'd be my 5 to 10. A little soft, but I think crowding out will reveal that we've done the wrong thing.
Yeah, I think that's an excellent point. I think the 3 to 5 year prediction with respect to this, I do think some of those limitations that you noted with respect to not on necessarily the technology side, but just human capital in order to make some of this stuff work. It's not there. And I think you're going to see some of the strain on this supply as those limitations are kind of exposed. And then it's a matter of, is the market going to pivot to new technology or new ways of handling this? Will chip design solve some of those problems? That's a little unknown, and that's where we're talking about that 5 to 10 and beyond. I also think, quite frankly, developments in quantum computing may drastically shift.
I was going to say nuclear or quantum in the 10-year window.
I think that is that combined with some of the capabilities of AI.
Yeah.
If the multiple facets that quantum computing can address, compared with the vast amount of data that AI can address, that combination could really shift a lot of what we're talking about in this marketplace. And either, depending on how that, because again, the infrastructure with respect to quantum computing is out of this world in terms of what we're talking about. But that, I think, you could see some major, really sort of developments there. At the same time, I think it's equally likely that the limitations you're talking about could lead to a real regression with respect to a lot of this technology, that it's just not possible. And that the models that they needed, the scale that they needed in order to make this profitable won't develop. And then where do you regress back to? What is it gonna fall back to, and where are you gonna see, technology at that point? And I think longer scale, I think those are equally possible. And it's unclear exactly where that will play out.
3 to 5, this is a hard question, David. I'm a little, I wrote down some comments and I'm realizing, gosh, I'm really skeptical. And, I don't know if that's a good thing or not, but I feel like what's going on right now is in some respects a land grab, and it's pretty speculative. One thing that concerns me the next 3 to 5 years is the subscription revenue model going to pan out in a meaningful way? Or are they just trying to get us hooked on it now for free and then start monetizing it? And is it going to be useful enough for people to keep paying more and more to justify the investment? I don't know. And I think we're going to have some clarity on that in the next 3 to 5 years, for good or ill, right? I think there's over provisioning going on because there's a risk of fear of missing out. There's a risk of missing out, and nobody wants to be, last one standing while their competitors have gone ahead to whatever. And so at the same time, they have huge cash reserves, right? And so there might be a little bit of a war of attrition going on. I think there could be a pullback from the lofty predictions of investment and what's actually really needed to make things happen. There could be a scaling back of expectations in the next 3 to 5 years. 5 to 10, who knows? I think quantum is a really interesting wild card to it all. And things like nuclear, and then farther down the road, it's always 30 years out, but fusion, things that could really upend things. I think that may be the place that a lot of these companies are looking to. They want to be there when that happens, because that's where, I don't know, endless profits or something is waiting for them, I guess.
Cryptography out the window at a minimum.
Yeah, right. So as a quick follow-up question for the rest of the panel, since you kind of anticipate a little bit, are we going to see an ad-based model used in order to recover some of these costs?
It's been the method in history says that's where they'll be
Highly targeted.
Yeah.
Well, so, and what I didn't hear really, but, you know, potentially you hear sometimes running around the broadband conferences is how AI is going to transform and fill up the local access pipe with traffic because each one of us are going to have personal assistants that relies on AI that's going to be multimedia. It's not just little messages that we get now or interaction that's data, which is low bandwidth, but it's pictures or you're storing what your glasses recovered or you constantly are recording. You remember what, 10, 15 years ago, there was a person who was recording every second of their life for a while. You remember? And that was like a big story. And with this technology, potentially could fill the pipe with a lot of personal information that, at least when I don't have a Facebook account, but a lot of people put a lot of pictures of what they do all the time on social media. And this could basically amplify that quite a bit, right?
I mean, if you don't pay for the product, you are the product, right?
Yeah.
Like, so if your data in this case is the product that you're not paying for.
But most of it's low bandwidth going upstream, so far, at least,
Yeah.
it seems to me. I mean, the Internet of Things, remember that? Where's that, by the way?
Yeah.
That's basically low bandwidth streams from devices going up. And I think that, a lot of that may play out kind of the same way. And, we're not all sitting here wearing Google Glass. There's some human nature going on here that I think the tech companies like to overlook.
But I am wearing a watch that.
I got to step in here because we got questions in the audience here.
Okay.
This is an amazing panel, and so we're going to take a little bit more time. You still get your break. In keeping with the Phil Weiser rule, do we have a question from a student, and our mic runners will come out to you? Otherwise, the first question I saw. Do we have a student right here? Yep, Dalton.
Well, Jeff, I want you to know I bought some meta stock on your assurance that I'll be bailed out. Aside from that, I think one of my thoughts, and we kind of talked around this bubble idea the whole time, but I want to advocate really quickly, and maybe this isn't my whole view, but I want to advocate for bubbles in the sense that it's driving a lot of investment in something that I think what Gordon talked about is the great unknown, right? And even if the timeline is really far off, we have put a lot of investment in this infrastructure that could possibly be used for other things. And then secondary to that, we're driving up cost, which also brings innovation because now we're saying, hey, it's a lot of energy to do this. These chips have gotten pretty expensive. Everyone's competing for the same chips. Like, how do we drive down these costs, which I think will also lead to innovation? And so what are some thoughts on advocating that maybe bubbles in some sense are good, like the broadband bubble brought a lot of infrastructure as well? So could you talk about that?
I think there's a valid point there. The broadband bubble is a good example, and the dot-com bubble it was a short-term, lots of pain, but long-term, lots of good, I think. And so that also kind of plays into the truism of technological advancement being overestimated in its short-term impact and underestimated in its long-term impact. And so I think some of that holds true.
I would add that there is nothing like I'll call it the venture world or the investment world or the risk-taking world of the United States. It's one of the characteristics that we have that other countries, even Western countries in Europe, don't have. And they think we're crazy. And then you show up and we're leading the world in a technology. And we take more risks and we chase more fun things and we put more at-risk money at things that may or may not work out than any other country. And I think you're right. We should celebrate a lot of this investment because the outcomes are ones we don't know today.
All right, I see another question up here. And I'm taking the MC's prerogative this afternoon, so we're going to go a little bit late, but your break is coming, folks. This is just a great discussion.
That was my fault. I was off an old schedule. I'll take that.
So thank you all for really providing a lot more depth to this, what I've been reading in the news articles. I want to play another scenario here in regards to creative constraint theory. And so we talk about, like, you've convinced me, the likelihood of us being able to meet the demand with supply and the timeline is pretty low. But if we use, the theory of, creative constraint, what ideas come to mind in regards to what we could do in that context?
Any takers?
I want to lean on Jeff in terms of optimizing the grid and utilizing the grid to its fullest capacity. I mean, the challenge with the grid is that in the 60s, 70s, and 80s, we actually had an overbuild of generation in the country. And then we had all the manufacturing go off seed overseas and load really stalled. And so we're asking these utilities to act very swiftly and very fast to bring on more generation and, more importantly, to bring on more transmission. And so I think the optimization and the efficiency gains in terms of the electrons, I truly hope that is what's something we can optimize.
All right, we're going to take 5 more minutes if we can. I see a question right here.
Yes, I'm assuming the demand's going to be there, and I think energy will become the long pole in the tent. And part of what we've experienced, I wrote a paper on the smart grid 10 years ago, and nothing has happened since then. And 10 years ago, they said Edison would have been intimately familiar with the grid, and he still would be. So do you think the fact that we need a new model, because we're in a highly regulated environment with utilities, they are constrained in how they can make investments, and there's things like microgrids. I mean, Google built a data center that used fuel cells 10 years ago. And you have control problems because renewable energy is intermittent. Will this, do you think, stimulate a new kind of model, like a new kind of company will come that'll be a combination of locally generated, of the microgrids? Because it's not all generation and transmission. There's a ton of things to the smart grid, and again, nothing happened.
Jeff, I'm looking at you.
Yeah, where to start? It is hard to replicate the grid behind the meter. I'll start there. Like a lot of people say it's easy, we'll add grid resources behind the meter and we'll make it as reliable as the grid. We take for granted the incredible engineering and thoughtfulness that has gone into creating the world's largest machine to be as reliable and as resilient as it is. So there are trade-off decisions with every engineering decision, especially around microgrids and behind-the-meter generation, that need to be considered. Yes, it's been done. You need something that has a higher capacity factor, like small modular nuclear reactors, to sit behind the grid to be able to island that seamlessly. That was number one. Number two, it's the old adage, we have 3 choices when we do something. We can do nothing. We all probably agree that's not right. We can build it bigger. That's what we're talking about, doubling the amount of fiber, doubling the amount of generation, maybe doubling the size of our grid. We're talking about $70 billion of 765 kV. Right now, the United States has very little of it, and we're talking about adding that. Or you can use it smarter. And I think the promise of the smart grid has not been realized. I think components of the smart grid have been implemented, but the total vision of this integrated system where we use our resources more intelligently has only come in small pockets on use case by use case applications. It's never been holistically transformed the way that the grid is used. When we talk to utilities about how they interface with hyperscalers, we say, number one, leverage their balance sheet. You shouldn't be taking some of the risks you're being asked to take. Number two, you need to be considering different commercial arrangements or models in the way that you work with them. Maybe it is part of an unregulated business, and we've seen that with Exelon spinning off Constellation and some of the things that they've been talking about publicly. I think that could be really exciting. And the third part of your question was around, like, can we use the technology of AI to solve grid problems? And I think you mentioned that. I don't know. I think the answer is yes, but how and when, I don't know. But part of using it smarter, we should take the technology that they're building and apply it to problems that we have. But the engineer in me, and probably David at the end there, would say physics always rules, and we're not going to invent a new type of physics as we go down this journey.
Yeah, I mean, I think some of the constraints that we're looking at with respect to the infrastructure build that have been noted, you Jeff and Gordon both have talked about the fact that maximizing what we have now is certainly a priority, and everybody is working towards maximizing every little bit that does exist now. And I think that will hit a limit, and then you'll have to see some innovation in that space in order to increase what is there, given the limitations with respect to construction, given the limitations with respect to, fiber and other, just physical constraints that are there. They're going to have to come up with a different approach. And that's where, the technology of AI that's been promised, that's one of the things that's supposed to be able to help analyze those large chunks of data to help come up with better solutions. Couple that with potentially the use of quantum computing, which can take that to another level, quite frankly, then you could potentially come up with new, potential solutions to that. And I think it is going to be
talking we're not talking like a marginal increase of like area under the curve that we're going to optimize for this like small time of one day, right? We've talked about the inverted duck curve in California, and if we do some load shifting and smoothing, we can solve these problems. I mean, yesterday we heard, I think it was 1.2 gigawatt system, and they have 2 gigawatts of connection requests, which means they're going to have to build a 4 gigawatt system. Like, there's nothing smarter to do there, like, unless we optimize something that we haven't figured out yet.
Yeah. Thanks, guys. One last question. I see a hand up right in the back there standing.
I'll be quick. Thank you very much. This has been so entertaining. It's taking me back. Let's see. 30 years ago, I think on February 8th, what did we have? We had the Telecom Act. And you guys were talking all about the big 4 powers coming, and the Telecom Act created the CLECs. And I think, what's going to happen when we don't service Easter Island and those local exchange characters? Is the federal government going to come in, and do we have a possibility of another data exchange act? So maybe we have CLADEX, for competition. Are we going to have to break up these big mega data center owners that are privatized?
Well, or are you going to see a stratification of the market? Are you going to see that there's supply and there's infrastructure for certain players, and others, they just don't get anything? That those who are looking for connectivity, in a smaller town or in a smaller area, that it's just not economically feasible, so they don't get it. And is that the result that's going to be forged out of this?
I mean, look what happened with the Telecom Act. You had the notion of breaking up Mobile, and it's going to land full of CLECs, and then they all consolidated, right?
Yeah.
And so, I mean, even if you can make the leap of the federal government politically having the wherewithal to break up the likes of these companies, which is unfathomable. Who knows, 10 years, whatever, but it could happen. I mean, they'd have to strengthen the Sherman Act a lot, I think.
Yeah. I mean, California's larger economy than the UK, and we're not going to kneecap ourselves in the world economy to break apart a company that we don't like what they're doing. History, again, probably says we wouldn't break apart a big company like that.
Yeah, I would think so.
Well, guys, this has been a great conversation. We're going to take about a 15-minute break here, but before we do so, give our panel and moderator a round of applause.